spent a lot of time and effort in the first videos to try to get you to understand the concepts behind what they're getting you to do. Now I'm going to go through the specific examples that they are showing you and giving you some practice at applying these concepts. So the first one is the given point lies on the terminal side of an angle theta in standard position. Find the values of the 6 trigonometric functions of theta. So all they're giving you as a clue is that your ordered pair is the ordered pair for 3. So since it's both positive x and positive y, I know it's in the first quadrant. I want to go 4 units to the right and then up 3 units. So if I'm in the right location, I'm not sure. But I want to call this the ordered pair 4, 3. If I do that, then I can complete the triangle by saying this is the hypotenuse. And then we know that the adjacent side is 4 because that is the x value, and the opposite side is 3 because that is the y value. And then a lot of you have memorized your 3, 4, 5 right triangle, so that should be a 5. If you don't, then you do 4 squared plus 3 squared equals your c squared, the Pythagorean theorem. And 16 plus 9 is 25, and 25 is equal to c squared, so c is equal to 5. So now we have the 3 sides of our right triangle, and what we can do is we can either use our definitions where the cosine is equal to adjacent over hypotenuse, or you can go x over r. Since I wrote it in a circle, I'm going to try practicing the x over r. So I need the x value over the r value for the cosine, and I'm not sure why I started there, but I got 4 over 5. The sine value is 3 over 5. The tangent value is nothing more than 3 over 4 since it's y over x. And then to do the reciprocals, it's 5/3, it is 5/4, and finally it is 4/3. So the first one is done. Okay, second one. What I'm going to do is I'm going to use the idea that both the x and the y are negative, so I got to locate the ordered pair -2, -1. So we go 2 units to the left, and we go down 1 unit. So maybe it's somewhere in here, -2, -1. I'm just using this diagram to help me draw a triangle and get the idea of the reference angles here. So we know that this side has a length of -2. We know that this side has a length of a -1 because of the sine values in the third quadrant. But when we calculate the hypotenuse, so we're going to do a -1 squared plus a -2 squared should equal c squared. I need to have the length of that hypotenuse. So it's going to be 1 plus 4 equals c squared, or c squared equals 5, or c equals the square root of 5. So we have radius, which is always going to be positive. Our legs can be negative on our unit circle, or even on any circle. This isn't really a unit circle, but we're going to go through and find all of our trig values. So even though we're doing theta is here, the reference triangle and reference angle is what we're using. So in this problem, the sine is a -1 over square root of 5. -1 over the square root of 5 simplifies to a negative square root of 5 over 5. The cosine of this value should be the adjacent side, or the x over the radius, which is a -2 over the square root of 5, which is -2 square root of 5 all over 5. And finally, the tangent is the y value over the x value, so it's the y value, -1, all over the x value, which is -2, or a positive half. Okay, so then, when we want to find the reciprocal functions, it makes it pretty easy if we have each of these sitting here. This is going to be the reciprocal, which is a negative square root of 5 over 1, or just negative square root of 5. This is going to be the reciprocal of -2 over the square root of 5, which is the square root of 5 over a -2, or negative square root of 5 over 2. And finally, the reciprocal of tangent is just 2. So, finding the 6 trig functions given a point on a circle or in the coordinate plane, all we got to do is draw our triangles and then finish it up with using our Pythagorean theorem to find the triangle's hypotenuse, and then using your opposite adjacent, or you can use your x, y, and r values.